Okay, our next exponent rule is exponent rule number 3, dealing with negative exponents. We are going to use an analogy that I like to think about it like this, because then I know what to do with it each time I see it. We're going to look at this fraction. It's a division problem, but every fraction problem is a division problem that hasn't been worked out. But I'm going to look at this as a top bunk of a bed and a bottom bunk of a bed. Now I want you to think it to yourself. If you had to choose between the top bunk and the bottom bunk, which would you choose? In my past experience, I've had people say, well, I like the bottom bunk because I don't want to climb the ladder. I've had other people say that they like the top bunk, especially about that elementary age. They like to be on the top bunk because it makes them feel big. And little kids, they don't like the top bunk because they're scared of heights. I don't like being on the bottom because I feel claustrophobic. So all of those reasons, wherever you stand, if you vote for top or bottom bunk, it doesn't matter. If you are placed in the opposite one, it gives you negative feelings. And so that's what's happening here with our variables and exponents. If a variable has a negative exponent, or if a number or a coefficient has a negative exponent, then it's not happy with where it's sleeping. So if we look at x to the third, well, 2 to the first, it has a positive exponent, positive 1. So it's happy with the top bunk. X to the third, happy with the top bunk. Y to the negative first, not happy with being on that top bunk. So we're going to take our y to the negative first, and we're going to put them down on the bottom bunk. Now when they go to the bottom bunk, they start feeling good and feeling happy again, and you'll see that happen in just a second. 4 is fine, has a first power, and so it's happy where it is. X to the negative second, not quite so happy. It's going to come up to the top. I would like to see you drawing circles and arrows so that we can tell where your different things are going. Y to the third is feeling just fine. So now we're going to rewrite what we have left. We have 2. Now this x to the negative second came to the top bunk, and so it's no longer feeling negative about its situation. So it's going to become a positive 2. And then we have x to the third is already up there. Now y to the negative first moved down to the bottom bunk. So we're going to rewrite him down there. So we have 4. X to the negative second's already gone. We have y to the third, and then our y to the negative first comes downstairs or down to the bottom bunk. And so now let's write, this is a division problem. So this is like exponent rule number 2. We're going to write it out. Now you may look at this and see that your x's aren't going to cancel out with your y's, and you may have a shorter method. This method will always work, and so we're going to practice this at the beginning here. So 2 goes into 2 once, 2 goes into 2 once. None of my x's and my y's cancel, and so I'm left with x to the 5th, because there are 5 of them, over 2, and I have 4 y's, y to the 4th, and we're done with that. Next, let's look at example number 2. In example number 2, remember x to the 0th power is basically just 1. So we can kind of cross them out to the 1 there if it makes you feel warm and fuzzy. X to the negative second, not happy with the bottom bunks, coming up top. So let's rewrite. We have 3, x to the second, because now he's happy, over 3, and then we have y squared, y to the 4th. So we can look at this, we could rewrite it and break it all down. I can see that my 3's are going to cancel. My x's, I don't have any x's in the denominator, like I don't have any y's in the numerator. So my answer is just going to be x squared over y's to the, I'd have 2 y's plus 4 more would give me y to the 6th. So that's example number 2. Now let's take a look at this type. If we were given, let's go with example 3, 4 a to the third, b to the 4th, times 3 a to the negative second. Well, how would you write a whole number as a fraction? Well, I would put it all over 1. And that's what we're going to do here. Now, 4 has a positive 1 exponent, happy with where he's sleeping. A to the third, B to the fourth. 3 has a positive 1 exponent. The negative 2 only goes with the A. And so that's the only guy that's unhappy where it's sleeping. So we have 4, and we could go ahead and write them out if we wanted to, but we have 4, A, B, 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 don't forget that 3, over A squared, or A. A's cancel out. Oh, when everything cancels out, remember we're going to write a 1. So I have 4 times 3, well that's going to give me 12, and I have an A, and then I have, looks like 4 B's over 1. Or we could just say that it would be 12 A, B to the 4th. So negative exponent unhappy sleeping arrangement, switch bumps. And then they become happy. They feel